Hello students, in this video we'll solve a competition problem related to finding the range of an altitude if two other altitudes of a triangle are known. Here's the statement of the problem. Suppose we're given a triangle ABC that has two altitudes of lengths 2, 3, and x. Find the range of possible values of x. Okay, so here's what we're going to do. So let's just get our bearings about us. So let's draw such a triangle, right? There's our triangle, A, B, C, like that. Let's suppose that the altitude from C over here, let's suppose that that altitude is going to be my, remember altitudes are the perpendiculars, right? That's what they are. Let's suppose that one is, let's see, I'll draw the altitude to B as well, like that. Let's suppose they look about the same, but let's say that C is 2 and then the B is 3, right? So that altitude over there, so in other words, what we're doing is that's the point over here. Let's call that point over here F. Let's call that point over here E. And let's call this point over here the altitude for A, which we're trying to find the range for, right? The altitude for A. Of course, the altitudes are concurrent, we know that, right? Let's call that point over here D. Okay? Good. All right. And so now, what can we say? So let's think about this carefully. So now I have this configuration. So let's let A denote the area of ABC. Okay, that's the key to unlocking this problem, the area of ABC. And then so what? And what we can do is the following now. So I know that the area, A, is equal to 1/2 of, let's do what? Let's do 1/2 2. That's the altitude times the length of AB, right? And so let's call the length of AB, let's call that length over there, let's call that C. Let's call this length over here A, and let's call this length over here B, right? As we typically do in a triangle. And so what's this one is going to be 1/2 of 2, that's the altitude over C, times C. Okay, great. And now what? Good. And so now the area is also equal to 1/2 3 times what? Times A, right? Good. Okay? And then finally what? And then finally, what can we say? Finally, we're going to say what? Finally, the last thing we have is we have the area is 1/2 x, which we don't know, times what? What's missing? 1/2 x. Sorry, so this, the 3 corresponds to the what? The 3 corresponds to the B. Sorry, that's going to be a B, not an A. That's a B. And then the x is what? The x is corresponding to the A. Great. So now I have these 3 inequalities. So let's equate all the areas. Equate all the areas. Okay. And if we do that, what are we going to get? We're going to get the following. We're going to have a 1/2. 1/2 times 2 times C is equal to what? Is equal to 3/2 times B is equal to what? Is equal to 1/2 times x times A. Or that's one thing we can say. I can also write this in terms of A. So what are all these things going to be? So now I can replace C with what? I can replace C with A. So this thing over here is just going to be A. What's 3/2 of B? That's just going to be what's 3/2 of B? That's going to be, so B is going to be what? These are all A, so I need to put A's everywhere. So what am I doing wrong here? So let me think for a second. Okay, so let me just think about this. So now we have those 3 things. Those are all representations of the area, right? All of these things are commonly equal to A. Now the next thing we're going to do is we're going to use the triangle inequality, right? So by the triangle inequality, what do we have? We have A minus B right, is less than C, and C is less than A plus B. So we get these things over here. And now I want to relate that, so I also get other relationships as well. So I need to have x in the middle. So which one has x? X is going to be the A. So I want to relate this to A. So B minus C, let's do it like this. So B minus C, so I need to get A in the middle, right? So B minus C is less than A by the triangle inequality, and A is less than B plus C. That's the triangle inequality. And so now we can fill those things in, right? So what's B minus C? So B minus C, what can we relate that to? We relate that to A, right? So we know that C is equal to A. So this is equal to A over here. So C is equal to A. And what do we know about B? We know that B is going to be what? It's going to be two-thirds of A, right? Two-thirds of A. Good. And so what's B minus C over here? B minus C over here in modulus is going to be what? It's just going to be A over 3. So it's going to be A over 3 less than what? A over 3 is less than A, which is going to be, what's A equal to over here? So A is going to be equal to area over, so I have area times 2 over x is less than what? Is less than B plus C. And what's B plus C? B plus C is going to be 5/3 of A. Great. Okay. And so now what we do is we divide by 2. Okay. And cancel out the A's because A is positive. So A cancel out the inequality. And therefore 1/6 is less than 1 over x is less than what? If I divide by 2, I'm going to get 5/6. So take the reciprocal of this and conclude what? And conclude that 6/5 is less than x is less than 6. And so that is the range of the third altitude if two of the altitudes are known. So what we do is we use the area as a bridge to get from one to the other, and then we equate the areas and then use a triangle inequality to determine the range of that last altitude. Thank you very much.